In today's lecture, we will learn one more other application of differential equations, and then we will solve some miscellaneous questions, and towards the end I will take one or two advanced questions also. Okay. So, can we start? In the last lecture we were learning the applications of differential equations. We had also solved this question of Stephen Hawking's idea. Now, let us solve one more real life application. Now, I framed this question on bacteria growth, but you can also apply similar ideas to human population growth, or you can also apply the same idea to pest control, pest act. So, for example, let us say you have cockroaches at your home. Using this model, you can predict after how many months you need one more pest control. So, you can also do it for pests of crops. For example, let us say you are doing farming and you have pests, rats or snakes or even other normal creatures also. So, you can study all kinds of population. Human population is little bit complex, but this will more or less suffice the idea of human population also. Okay. So, you can read the question. Of course, I will develop the mathematical model, but let us read the question first. So, question says population of a bacteria is undergoing logistic growth. In fact, this word logistic growth, it has a meaning because in mathematics there is an equation called as logistic equation. We will see what that logistics equation is. Okay. Under limited resources. So, growth is under limited resources. What does this mean? This means if resources is, let us say, limited, then population cannot go beyond a certain value. Okay. For example, let us say there is only 100 kilos of rice available, and we are talking about how many people who can survive with that 100 kilos of rice. So, even if one person eats, let us say 1/4 of 1 kilo, so every person needs 1/4 of a kilo, so 400 people can eat that 100 kilos of rice. Now, if every day food supply is only 100 kilos, but if human population is continuously increasing, then what happens? When supply becomes less and number of humans is more, then people will start killing each other for food. This is what used to happen in earlier days when this green revolution and all these things did not come. Okay. People fight for food, people kill each other for food also. Okay. So, there is a upper limitation because resources are limited. Okay. So, you can imagine that if resources are limited, then there is a upper cap on the total population that is possible. So, in the next phrase it is given that maximum possible population is only 100,000. So, bacteria can grow only till 100,000 due to the limited resources available. Let us say you are solving this question in a lab, you have one simple test tube where you have put minute amount of food and there is little bit of bacteria there. So, you can test whether bacteria will survive or not without having food. Okay. So, this is the idea. So, there is an upper cap on the overall population. Okay. So, now let us read the next phrase. Initially, the bacteria colony has 500 members. So, if we take the population as P, P stands for population, then P naught is given as 5,000 members. Okay. So, P naught is given as 5,000. And what else? Population is increasing at a rate of 400 per minute. So, that means at t equal to 0, dp by dt, that is the rate of change of population, is 400 per minute. This is the initial value. And then we have to calculate how large the population will be after 30 minutes. When will the population reach 80,000? Okay. So, these are the problems, but before we go ahead with the problem, we have to of course develop one mathematical model. So, the model that we are going to develop here, it is called as logistics equation. So, let us look at the simple analysis of the population. Okay. So, let us say there are 10 boys and 10 girls, or 10 males and 10 females. That means there are 10 couples. So if these 20 people reproduce, then by tomorrow, how many new members will join the population? There are 10 couples. So each couple, let's say, is giving one child. So that means by next day it will be 30. So here you can understand that the population increment will depend on the current population. For example, let's say there are 1000 couples today. So by tomorrow number will increase bigger. So population rate must be proportional to the current population. So that is one idea that we are concluding. It must be proportional to the current population. Now let's look at this limited resources. What does this mean? This means we have to check whether the population growth is actually complemented by the supply of the food or not. Okay. So there is an upper cap of the limitation. If we take the upper cap as, let's say, P max or PM, we can take this as 100,000. So if we subtract the current population from the total population, that is PM minus P, this will actually give us the extra food that is available. Okay. So there must be a constant multiplying this, that we can take as some K or something, that anyways we will include in the proportionality. So we can also say that dP by dt also must be proportional to the difference of the max minus the current population. This will actually give us the surplus amount. Okay. So after these many people are eating the food, how much food is available as extra? If there is extra food, of course population will keep on increasing. If there is no surplus amount of food, if there is no extra food, then population will not increase further. Okay. So as I said, if there is no food available, people will start killing each other. Even for bacteria, if there is no food available, it will start eating itself. Okay. So here, by combining these two ideas, we can say that dP by dt must be equal to 1 proportionality constant into P into PM minus P. This equation is called as the logistics equation. This represents population growth. Okay. So in most of the cases, bacteria, virus, pests and animals also, we can use this idea. Okay. Assuming that there is no other human intervention, if resources are kept as constant and if we put that population there, it will grow according to this formula. Okay. So now the job is to basically integrate this and get a solution. Okay. So till here what we have done is we have tried to understand what are the main factors involving the population growth, how to model it mathematically. Okay. So we finished the mathematical modeling process. Now we have to solve it. Okay. So how do we solve it? We can see it that it is of variable separable method. So let us just solve this. So we will get dP by, I will take both terms having P to LHS, P into PM minus P is equal to K into dt. Okay. So we have to solve this using partial fractions only. So LHS can be split into two fractions involving like this. Now if I add these two, in the numerator P will get cancelled, but PM will remain. So we have to balance this by dividing with PM and into dP. This must be equal to K into dt. Okay. So now we can integrate this using simple ideas. So if I send, let's say, 1 by PM to the other side, okay, so we'll get dP by P here plus dP by PM minus P, and this is equal to PM into K into dt. Okay. Now when we integrate, what do we get? We get ln P here minus ln PM minus P is equal to PM into K into T plus some constant, let's say C. Okay. So here we can combine these two logarithms and write the ratio of the terms. So this LHS will basically become ln of P by PM minus P, and RHS is PM into K into T plus C. Okay. So now if I take ln to the other side, it becomes power of exponential. Okay. So we will get an expression like this: p by pm minus p is equal to e raised to pm into k into t into some c star, which I am taking it as e raised to c. Okay. So this is the function that we got after integrating, but this process is a simple process. So in mathematics, algebra process in real life applications, algebraic process is actually very simple process, but analyzing each and every term is very important. That is what takes the longer time than the solving part. Okay. So we got one expression for this model. Now let us apply these initial conditions and get the constants. Okay. So if I apply initial P naught to be 5000, I can get the integration constant C star. Okay. So at t equal to 0, P naught must be 5000, right. So which means 5000 divided by 100,000 minus 5000, this must be equal to C star into e raised to 0, e raised to 0 is 1. So this will come out to be how much? 3 zeros will anyways get cancelled. So it becomes 5 by 95, which is 1 by 19. Okay. C star is basically 1 by 19, we got one constant. Now we have to get k also. To get k, there is one more initial condition given, we will also apply this condition and get k. Okay. So at t equal to 0, the rate of increment of the speed of increment of the population must be 400. So we can apply right here itself and get the k. Okay. So here k can be calculated. So k is equal to 400 divided by, what is the initial population P naught? It is 5000 into PM is 100,000 minus P naught is 5000. Okay. Now when we simplify this, what are we going to get? 2 zeros will get cancelled. So we will get 4 by 50 into 1 by 95,000, right. So that is k, but we have Pm into k here. So let me just evaluate Pm into k also. Okay. So when I multiply this with Pm, what do we get? Pm into k is equal to 100,000 into 4 by 50 into 95,000. Okay. So these 3 zeros will get cancelled. So 50 into 2 is basically 100. So we are basically getting 8 by 95. This is our Pm into k. So we can write this function as P by Pm minus P is equal to e raised to 8t by 95 into constant C star is 1 by 19. Okay. Or we can also further simplify this and write. Okay. So it does not matter. So let me just write it here. So when we cross multiply, we will get 19p into e raised to minus 8t by 95. This must be equal to Pm minus P. Okay. So from here we can calculate P to be P equal to Pm divided by 1 plus 19 into e raised to minus 8t by 95. Okay. This is the resulting function. Now in this function, after you derive the function, you have actually solved the problem completely. Now you have to just put the values and get the required values. Okay. So let us say we want to find the population after 30 minutes. So at t equal to 30, P will be equal to P max divided by 1 plus e raised to minus 19 into e raised to minus 8 into 30 by 95. That is it. You simplify it and get the required value. That way we can get the overall process. Okay. Let us do the second one. Okay. So this seems fine. Now the second one is when will the population reach 80,000? So that means we have to put 80,000 here, that is equal to PM is 100,000 divided by 1 plus 19 into e raised to minus 80 by 95. So here we can directly simplify and get some expression for T. Okay. So this way we can solve the process. Okay. So here if you understand, the main idea is to represent the population using our common sense. That is the main aspect here. Okay. So I hope you have liked this analysis, discussion and also the equation. This equation is very special. You will learn this in science and engineering. Okay. Come on, make a note of this. Next page also. Okay. So can we move on? Here I have not completed the calculations because we need either a calculator or log tables here, but that I am leaving to you. Okay. So you try to do it, and here I think the time will come out to be somewhere between 100 to 200. So basically in if you take the average also 150, so roughly 150 minutes the population is going to grow to 80,000. So here you can understand how fast actually bacteria grows. Okay. It actually grows initially, if you look at 400 new production per minute. Okay. So that means even if someone sneezes and you are standing there, and if that cold bacteria enters your nose or lungs, within hours it will multiply into lakhs. Okay. So that is why if we catch cold or anything bacterial infections very fast. Okay. Okay. So can we proceed to the next questions? So with this we will close all real life applications of differential equations. Now let us look at algebraic applications and JEE mains and JEE advanced applications. Okay. So there is one question here. This question is actually confusing question, but before we go to this question, let us once analyze the entire chapter in a simple thought process point of view. So whenever you get any question in differential equations, what is your first step? Your step 1 is to develop the mathematical model. This is your first step. Okay. If mathematical model is already given, what exactly is the mathematical model? Differential equation. Differential equation is the model. Equation, set of equations is the model. Okay. So after you develop the model, or let us say if it is already given, then you will think of solving that differential equation. So now when it comes to solving, what is the first thing that you have to notice? Order and degree. Okay. So check order and degree. Okay. So now once order and degree are checked, then you can proceed further based on the order and degree. Okay. So if it is first order, then you go for the methods that we have learned till now. Okay. So first order. Now here again, what is the first method that we attempt? Variable separable method, because that is very easy method. Okay. So this is our step 1, variables separable. Okay. Now after this method is, of course, when we look at the equation, we know whether it is separable or not. Okay. And if this is not working immediately, then do not go for exact forms, go for linear check and the homogeneous check. Okay. So if it is linear or homogeneous, these you will check, homogeneous differential equation or linear differential equation, these two you check. Now if these two don't work out, because if you look at the equation you will see it on the spot if it is linear or not, okay. So because there is standard form for these two, okay. Now if these don't work, only then we will go for the exact forms, because exact forms are generally time consuming and they will be confusing also, okay. Now if these, let us say, do not work, then you go for the miscellaneous forms. What are the miscellaneous forms? Convertible to linear, just like Bernoulli's equation, convertible to homogeneous, these kind of ideas you will try to check, okay. So this way we will handle all first order differential equations of this standard, okay. Now what if we get second order equations? Second order means double derivative is involved. What is the idea to solve equations involving second order? We have also discussed this in the last lecture or last to last lecture. We basically convert them into linear and then try to solve them, okay. So now when we convert them into linear, there could be different ideas also, okay. So mostly we solve them only by converting till now. These are only the ideas that we have learned till now, okay. But still we can still proceed using these ideas at this level. But if you are going for the next level, let us say engineering and science, of course these methods may not work, you may need more advanced knowledge, okay. So this is generally our thought process of handling differential equations. Now let us look at this equation in this systematic way. So if we look at this equation, there is dx, there is dy, so it is first order, okay. So that means from this chart if you observe, only we have reached only this part. So let me verify which method works here. Now can variables be separated? Of course not, because x by y by x cannot be separated, they are inside sine and cos, okay. So variable separable failed. Now can we convert this into linear differential equation, LDE standard form? Of course not. So LDE also failed. But because there is x by y by x involved, it may look like a homogeneous equation, it may look like, but it is not, because here if you check the degree is 1 by linear, here also it is 1 by linear, okay. So it may not work here. But if you divide with, or if you multiply with x or divide with x and try to convert this into homogeneous form and try to solve it, you may be able to convert it, but it will take hell lot of time, okay. So here the method that I am applying is the exact forms, okay. So this is just an example of how confusing it could be. It may look like homogeneous, but it is not, okay. So let me use exact forms idea here, okay. So that is all for the discussion. Let us proceed into the solving now, okay. So in this equation, what are the terms which do not cause any trouble? This 1 into dx is the term and this 1 by y square into dy is the term which do not cause any trouble. So let us separate these terms and solve them first, okay. So 1 into dx, this is one term, plus dy by y square, this is another term. These two terms do not have any issue, they are easily integrable. Now that means we have handled this one, we have also handled this 1 by y square, okay. Now let us look at the other terms. Other terms are involving y by x in some terms and x by y in other terms. See, that is exactly the problem that I discussed here. If you had gone to the homogeneous forms, you must have assumed y by x as z. So if y by x becomes z, x by y will become 1 by z. It creates another headache to integrate sine of 1 by x, okay. So that becomes a headache. So hence we are using these ideas, okay. So there are some terms with x by y, there are some terms with y by x. But if you observe the x by y, it is coming with only sine function and y by x is coming only with the cosine. So let us separate sine and cosine and then try to see if they can be integrated separately, okay. So if I take sine x by y common, so what are the terms that are coming with sine x by y? Here we have 1 by y into dx, right. So, we handled this term, and there is 1 sin x by y here. So, we have x into dy by y square. Okay. So, this is sin x by y. Now, let me take cos of x by y also, sorry, cos of y by x also common. Now, what are the terms that are coming out with this? Here we are getting minus y dx by x square, and here we are getting plus 1 by x into dy. Okay, so we separated the terms. Now, my idea is simple. If this x by y can come as exact form, then this can be integrated directly. And here that is what I am going to check if this works out or not. Okay. So, what I will try to do is I will check d of x by y. So, what will this give us? It will give me y into dx minus x into dy by y square. Now, when I divide with y square, what do I get? Dx by y minus x by y square into dx. Now, luckily this has matched. Now, because this has matched, it has given me confidence to try the same idea for the next term also. Okay. Suppose let us say if this did not match, then we will go for some other trials. Okay. So, here I will check d of y by x. It becomes x into dy minus y into dx by x square. Again, if I divide, I will get dy by x minus y dx by x square, and this also matched luckily. So, hence the problem is solved. Okay. So, let us complete the process. So, we are basically getting sin of x by y into d of x by y plus cos of y by x into d of y by x. Okay. And what else? Plus 1 into dx plus dy by y square is equal to 0. Now, I think this can be integrated very easily. Okay. So, integral, integral, integral and integral. Okay. So, what do we get here? Here we will get minus cos of x by y, and here we will get plus sin of y by x, and here we will get x, and here we will get minus 1 by y is equal to constant c. Okay. So, this way we can solve this problem. So, here if you observe, there could be little confusing terms also, but then we do not have exact surety of which method is going to work. So, we have to go for hit and trial ideas and keep trying. Okay. So, that is how we solve most of the questions. Come on, make a note of this. This page also. Okay, so now let us go to next question. Okay. So, this is also in similar form. Okay. So, what is the idea? First check other forms. Can variables be separated? No. Is it in standard linear differential form? No. Is it in the homogeneous form? No. This term and this term are in the homogeneous forms, but this 1 by x and 1 by y terms are not in homogeneous forms. So, hence overall no. So, homogeneous also failed. So, we have to try the exact forms. If we want to try the exact forms or miscellaneous forms, what is the idea? First separate the terms which can be easily integrated. So, here what are the terms? 1 by x into dx can be integrated easily, and that means this term is taken care. Now, we will take care of this term. So, minus 1 by y into dy, this is also easily integrable, and remaining both terms have same denominator. So, what I will do is I will take x minus y whole square common in the denominator. Now, what is coming in the numerator? Here we are getting plus x square into dy, and here we are getting minus y square into dx. This must be equal to 0. Okay. So now this is easy. Okay, so message sent and student has seen the message, sent and seen, but this has trouble. So how do we handle? Again we have to go for hit and trial ideas. Okay. Now is it in any standard exact forms pattern? Of course not. We have discussed some forms in the lecture, but this is definitely not in that form. So every time whatever we discussed in the lecture need not come in the exam also. Okay. So you may have to work out your way. Okay. So how do we proceed here? So there is x and there is y here. So both are combined. They cannot be separated. So that means in the numerator also it must be one of the differentials of both combined form of x and y. Okay. So the ideas here goes like this. Here there is x square with dy, here there is y square with dx. If I take x square and y square separately, that means if I take, let us say, x square into y square common, what do I get? I get dy by y square minus dx by x square. Okay. So just think about the term whose derivative is this. We know that d of 1 by x is basically minus 1 by x square into dx. Okay. Similarly, d of 1 by y is minus dy by y square. We know these ideas. So the moment I taken this common, I suddenly remember that there is a form which will give these terms as differential, right? So what I will try to do is, I will try to convert denominator also into reciprocals. So that means if I want to convert x minus y into reciprocals, what do I have to do? If I divide this with xy, so I will get 1 by y minus 1 by x, right? So if I divide, I have to multiply also. So denominator will come out to be x square into y square into 1 by y minus 1 by x. Okay. So now I can understand that this is actually in exact form. Okay. So but there is only one problem here, square is there, so problem is eliminated. So what is the problem? If we directly go for d of, let us say, 1 by x minus 1 by y, we are going to get minus dx by x square plus dy by y square, which is the numerator. So denominator also must be of the form 1 by x minus 1 by y, because there is square here. You write a minus b or b minus a, it does not matter inside the square. Okay, so we cracked this term also. Okay, so let me rewrite all this in a fresh form. So we got 1 by x dx and also we got minus 1 by y dy. Okay, and plus x square y square in the numerator and denominator got cancelled. So we got d of 1 by x minus 1 by y divided by 1 by x minus 1 by y whole square. This is equal to 0. That is it. After this it is cakewalk. Okay. So how do we integrate this? It is a simple integration. So we will get ln x here minus ln y, and here we will get plus 1 by x minus 1 by y whole raised to minus 2 plus 1 by minus 2 plus 1 equal to constant. So further we can write it as ln of x by y minus 1 by x minus 1 by y equal to c, or we can also further simplify this, ln of x by y minus, what do we get here, xy divided by y minus x equal to constant c. Okay. So this way we can solve the miscellaneous kind of questions. Okay. So I hope you are liking these questions. Come on, make a note of this. This also. Okay. Let us go to next questions. So now I am taking up some questions of advanced level. Okay. So, this question is actually based on functional equations. You might have studied functional equations in functions, but here we are actually mixing functional equations with differential equation and with derivatives also. Okay. So, before we solve this, let us first observe what are the functional equations and what is the better method to handle them. So, when it comes to functional equations, what are the ideas that you have? One idea is using substitutions. Okay. Second idea is guessing the function. Okay. Third idea is use differentiation and integration to solve the question. Okay. So, use differentiation and integration to solve the question. These are the main ideas. Okay. So, substitution ideas we might have discussed in functions, you might have seen the functions lectures, else you can also watch the functions chapter in 11th standard when we cover it. Okay. So, substitutions means put x equal to 0, x equal to 1, x equal to 3 and then observe the pattern and then based on the pattern generalize the pattern and get the function. That way we can do that. And guessing the function needs a little bit of knowledge of the pattern of the functional equations. For that we have this standard set of equations which are also called as the Euler's equations. What are these Euler's equations? Let me just give you that list also. Okay. Euler's equations. There are 4 standard Euler's equations. One is f of x plus y equal to f of x into f of y. Second, f of xy equal to f of x into f of y. Third, f of xy equal to f of x plus f of y. And fourth, f of x plus y is equal to f of x plus f of y. Okay. These 4 are called as the Euler's equations. These are pretty standard equations. You can guess the function by looking at the pattern. So, if you want to guess the function, try to recall any property that you have studied in your algebra or functions or calculus anywhere from the list of functions that you have studied and try to match that property with this. Now, what are the functions you have actually studied? You have studied all trigonometric functions. You have studied inverse trigonometric functions, logarithmic, exponential, polynomial functions and rational functions. What else did you study? Exponential, logarithm. These are only the main functions and of course there are some special functions. So, remembering all these properties is not that tough. If you had solved questions, you might have remembered the properties also. So, when we look at these equations, we generally get that idea very fast. For example, let us say if I list down some functions, but these are not the only functions, but I am listing down some functions. For this we have exponential e raised to x, a raised to x and so on. Okay. And what about this? For this we have x raised to n, mod x, mod z complex function. Okay. And what else? Signum function. Okay. Dirichlet function. There could be functions like this. And for the third one, what is the function? Log function, log of x base a. We should always take the general base. Okay. Or we can also get argument of z, this is complex function. Okay. And based on that you can search for the other properties also. What about this function? It is going to be kx. Okay. So, this way you need to remember these forms to guess the function. Now, there could be other properties or other equations which could be converted into these forms also, but these are the major forms. Now, just because I wrote 4 forms here, all functional equations of guessing method need not come in this form only. Okay. So, there could be more derived forms also that you have to explore. So, guessing is one idea. Using differentiation and integration, this method is used when there are derivatives and integrals involved in the question. For example, this question where f dash of 0 is already given, so we have to use the differentiation here. Okay. So, I hope you have understood the idea. Suppose let us say this f dash of 0 is not given, then we can go for the guessing of the function. Okay. So, let me solve this question using both methods. Okay. So, I am sure you will learn from both of them, and in the exam you use whichever is comfortable to you. Okay. But remember, if there are differential terms and integral terms involved, then go for this third idea only. Okay. So, I have discussed how to handle functional equations. Now, let me solve this question. So, because derivative is involved, I will start with the definition of the derivative. Okay. So, what is the definition of derivative? F dash of x is equal to limit h tending to 0 f of x plus h minus f of x by h. Okay. This is the definition. But f of x plus y is given as something and it is satisfied for all x and y belonging to R. So, we can use this here. So, what do we get? We get limit h tending to 0 e power x into f of h, because in place of y I am substituting h, plus e raised to h into f of x minus f of x divided by h. Okay. Now, I can split this into two terms. So, a limit h is tending to 0 e power x into f of h by h, plus if I take f of x common, I will get limit h tending to 0 e raised to h minus 1 by h. Okay. So, here also I can take this e raised to x common. So, let me just take it common and write it here. So, e raised to x into limit of h tending to 0. Okay. So, basically limit is applied on h. So, x can be taken common, assuming that it is constant with respect to that limit. Okay. So, here there are two limits. The second limit is very standard limit and this has to be equal to 1, right. What about the first limit? We do not know what kind of form this is, because we know for sure that denominator is 0, but we do not know about the numerator. So, to know about the numerator, we need to identify the or calculate the value of f of 0. To get f of 0, put x equal to y equal to 0 in this. Okay. So, if we put x equal to y equal to 0, what do we get? We get f of 0 in the LHS, and in RHS we will get 2 into f of 0, which will give the value of f of 0 to be 0. So, now it is clarified that this limit is of the form 0 by 0 form. So, if this limit is of the form 0 by 0, we can apply L'Hospital rule here. So, that means we can write this as e raised to x into f dash of 0 plus f of x. Now, how did I get this f dash of 0? By applying L'Hospital rule. Now, what is given as f dash of 0? It is 3. So, we basically got f dash equal to 3 into e raised to x plus f. Okay. So, I hope you have understood the main idea here. So, after we applied the definition of the derivative, we got one differential equation. We solve this differential equation to get the function. So, this is how we handle functional equation if it involves derivatives or integrals in the given question. Okay. So, I hope you have understood this idea. Okay. So, that is exactly what we have done here. Now, let us solve this. So, I will take f of x as y. So, which means this equation will become y dash minus y equal to 3 into e raised to x. I have taken f to LHS. Now, this is linear differential equation. You know the method. We have to go for integrating factor. So, what is the integrating factor here? It is e raised to integral of minus 1 dx. This will give us e raised to minus x. So, if I put it here, so integrating factor into dependent variable is equal to integral of 3 into e raised to x, that is RHS into integrating factor dx. Okay. So luckily RHS has become 3x plus some constant c. Okay. So y becomes 3x into 3x plus c into e raised to x. Now put the given condition. What is it? F of 0 is 0. We basically derived it. Okay. So that means at x equal to 0, y also must be 0. So that will give us 0 equal to c into e raised to 0, which means c is also 0. So y equal to 3x into e raised to x is the function which is f of x. Okay. So basically here you have understood the overall method of the problem. Okay. So this is the standard method. But let me explain you the application of Euler's equations on this. Okay. So this is method number 2. We basically have this equation f of x plus y is equal to e raised to x into f of y plus e raised to y into f of x, right. Now I will divide this equation both sides with e power x and also e power y. So I am dividing with both e power x and e power y. Okay. So this will turn out to be f of x plus y divided by e raised to x plus y is equal to, here we are getting f of y by e raised to y plus f of x by e raised to x, right. Now let us say if I assume this f of x by e raised to x as, let us say, g of x, then this term becomes g of y, this term becomes g of x plus y. So we can write this as g of x plus y is equal to g of y plus g of x. Okay. Now look at this form. Is it in any one of the standard Euler's equations? Just see. It is in this fourth form. So what is the function that we can guess? Kx. So we can take the function as function g of x as kx, but g of x is nothing but f of x by e raised to x. So f of x by e raised to x must be equal to kx. So which means f of x is equal to kx into e raised to x. So I think we straight away went to this step. Okay. Sorry, we straight away went till this step, but here c is not there. There is a different constant k that we will get by substituting the idea of the derivative. Okay. So if we differentiate this, what do we get? F dash is equal to k into e raised to x into x plus 1, right. So if I put 0 here, what do we get? F dash of 0 is nothing but k, and this must be equal to 3. This implies that f of x is 3x into e raised to x. Okay. So this is the whole idea of this question. Okay. But this idea of guessing the function may not work every time, because the function may not be of the standard forms also. Sometimes in some questions function itself is not asked. So then we may have to stick to this standard method. Okay. So out of these two methods, if I want to vote, if you ask for my preference, priority, I would say this: if derivative terms or integral terms are not involved in the question, guessing method is the best method. If derivatives are involved or some integral is given, 0 to 1 f of x dx is phi or something, such kind of values are given, then this method is the calculus method is the best method. Okay. Come on, make a note of this. Next page also. And also this page. Okay. Okay. Now, let us look at another question. This is actually a second order equation and we want to solve this. All the methods that we have learned are of first order equations. So, how do we handle? We have to convert this into first order equations. But this is not second degree equation, it is not second degree equation. If it was second degree equation, we will solve it using simple quadratic polynomials or something and then try to convert them into first degree and then try to solve it. But here it is second order but first degree. So, how do we handle this? Use this idea. So, in future also if you get questions of this kind, remember this idea and try to do it with this idea. So, what we do here is we subtract y dash and add y dash and put y dash minus y equal to z. Then what do we get? We get z dash as y double dash minus y dash. So, here the equation got converted into z dash plus z equal to 2x. Okay. So, now this is in the standard form of linear differential equation. So, you know how to solve this. So, integrating factor here is basically e raised to x. You know how to get this. So, e raised to x into z equal to integral of 2x into e raised to x dx. So, you know the integral of this which is by integration by parts. So, that will come out to be 2 into e raised to x into x plus 1 plus some constant c. Okay. But if we let us say divide with e raised to x here, so what do we get? Z is equal to 2x plus 2 plus c into e raised to minus x. But what is z? Z is nothing but y dash minus y. So, again this is now converted into another linear differential equation and we have to solve this. Okay. So, this way we can finish the problem. I am leaving the solutions to you. Okay. But there is one more interesting advanced level question. Let us discuss this question. Okay. So, look at the question is big. Okay. And this is of course one paragraph kind of question. Here f of x is already given as non-positive function. So, that means it can be 0 or it can be negative also. And f of x is given in terms of an integral. So, we have to go for the calculus ideas, we cannot go for guessing functions. Okay. And here there is a relation given and also there is another relation given on g of x which is another function and we have to comment about these. Okay. So, let us start with generating the function. Okay. So, let me take f of x. Okay. This page is completely for f of x. Okay. So, what are the given ideas here? Capital F of x equal to 0 to x f of t small f of t dt. Now, when I differentiate this using Newton-Leibniz theorem, we will get small f of x equal to capital F dash x. Okay. So, let us keep it aside. And what is the next idea? F of x is greater than equal to c into capital F of x. So, small f of x is greater than equal to c into capital F of x. We can write this as small f of x minus c into capital F of x is greater than equal to 0, right. Now, small f of x is same as capital F dash x. So, it becomes capital F dash minus c into capital F greater than equal to 0. Now, look at this. Isn't it looking like linear differential equation? Of course, it is. See here, whenever you get functions like this, do not directly go for simple ideas of differentiation or something. Okay. So, go for systematic ideas. So, here if you calculate the integrating factor. So, integrating factor will be e raised to integral of minus c into dx which is e raised to minus cx. Okay. So, this will come out to be e raised to minus cx into f of x is greater than equal to integral of e raised to minus cx into 0 into dx, right? That way you can understand, or you can also write it this way. You can say that this is equal to derivative of this function LHS, that is in the LHS, greater than equal to 0. So basically what I have done is I have multiplied this equation with e raised to minus cx and got this result. So this means e raised to minus cx into f of x is basically increasing function, right? But it's already given that c is basically a positive number. So e raised to minus cx is a decreasing function, right? E raised to minus cx, the graph of that will look like this. It is a decreasing function. So hence f of x must be even more increasing function. So capital F of x is also increasing function. Okay, so we have understood this. Now let's look at the other values given. Here if I put x equal to 0, what do I get? Capital F of 0 equal to integral 0 to 0 f of t dt. This will be 0 only, right? So capital F of 0 is 0, okay? Capital F of 0 is 0, and after that it has to be increasing, okay? So what is the meaning of increasing here? It could be either a constant or it is strictly increasing, one of them is valid. Now if we look at the capital F of x here, okay, so let me explain it here. It's given that small f of x is a non-positive function. So when we integrate a non-positive function, we either get the integral to be completely positive, completely negative or 0, right? Completely negative or 0 it must be, okay? But here if we check, f of 0 is 0 and after that function has to increase, but here integral must be negative or 0, which means capital F of x is a constant function. Okay, because capital F of x can never be positive, that is what this statement told me. It is integral is either negative or 0, and here it says it is increasing function, but it has to start from a level of 0. After 0 it has to be always negative or 0 and it has to be increasing function, so it must be a constant function. I hope this is clear. So f of x must be 0, okay? It must be always 0. If this integral is always 0, small f of x also must be 0 function, okay? See, after doing so much hard work we still got 0 function, but that is fine, okay? Now let us look at the g of x function. So what is the given condition here? G dash is less than g of x, okay? So g dash is less than g of x, which implies g dash minus g is less than 0. Here also we can multiply with integrating factor, which is e raised to minus x into g dash minus e raised to minus x into g, this is less than 0. Basically I multiplied with e raised to minus x. Now this LHS has become exact derivative of e raised to x into g of x. Now this must be 0, which implies that e raised to minus x into g of x is strictly decreasing function, okay? By monotonicity we can say that e raised to minus x into g of x. So this is like for all x greater than 0, this value when compared to e raised to minus 0 into g of 0 must be smaller, because function is strictly decreasing function, right? Now e raised to minus 0 is 1. Let us look at g of 0 here. G of 0 is given as 0. So RHS is basically 0. So that means e raised to minus x into g of x must be always negative. And we know that e raised to minus x is always positive number, which implies g of x must be a negative value. If g of x is negative value, So that means how would the function look like? G of x is equal to 0 if x is 0 and it is negative for all x greater than 0. This is the definition for g of x. So we basically got one definition for f of x and we got one definition for g of x. So we cracked both functions using mixing of all these ideas of calculus. Now let us look at the problem. What is the first part? We have to find the number of solutions of this. Okay. So I will just take 1 or 2 minutes and complete these questions. Okay. So this is the first question. We know that f of x is always 0 and g of x is 0 at x equal to 0 and it is negative. Okay. So when we go for f of x plus g of x, what is the resulting value? It is 0 at x equal to 0, it is negative for x greater than 0. For x less than 0 it is not defined. Now if we look at this function, because there is modulus involved, it could be non-negative. So if it is non-negative, that means it is either 0 or it is positive. So here it is 0 or positive, here it is 0 or negative. So what is the match here? For the solutions to exist, both must be equal to 0. Now if I solve for the roots of this LHS, the roots are going to be x equal to minus 3 and x equal to 2. These are the roots of LHS. But for these values do not match in RHS. So this has no solutions. Okay. So I hope this is clear. Now let us look at the other. F of x equal to g of x, it has only one solution which is at x equal to 0. This is the only solution. So answer is only one solution. Okay. Now let us look at the third part. Here we have to solve this inequation. But we know that at x equal to 0, g of x is 0. So that could be one solution. Okay. Now next case, if x is greater than 0, then g of x is definitely less than 0 and we want the overall product to be less than equal to 0. So hence this implies that cos inverse x minus sin inverse x must be greater than equal to 0. Now how do we solve this? Using simple graph we can understand. So let me draw the graphs of sin inverse and cos inverse. Okay. So sin inverse graph is somewhat like this. So I have just stretched the graph a bit. This is 1 and for cos this value is pi by 2. For cos we will get graph like this. Okay. And both these match at the value which is 1 by root 2. Okay. Now let us see what do we want. We want cos inverse to be greater than equal to sin inverse. So we want this cos inverse graph to be greater than equal to sin inverse. So for what values is it possible? Because if you check the domain of g of x function, it is only 0 and positive values. So this negative part is neglected because it is not in the domain. Okay. So we have to take only the solutions which are positive. So starting from 0 till 1 by root 2, all values are possible. Okay. So here from 0 till 1 by root 2, all values are possible. Okay. So now overall what are the solutions? The answer must be starting from 0 closed interval to 1 by root 2 closed interval. Okay. So this way we can finish the problem. But here solving the next parts also involve another technique, that is another task, but cracking the function is the main step. Okay. So I hope you have liked this question, liked the discussion and the analysis. Okay. So with this we close the chapter differential equations, and from the next lecture onwards we will be starting a new chapter. I hope you have enjoyed the entire chapter. Now you have to practice well and develop problem solving skills and examination skills. Okay. So we will meet again in the next lecture. Until then, have a great learning day. Learning shall never stop.